Okay, Bismillahir Rahmanir Rahim. Okay, Sidra and Alize, tell me, what do you know about momentum already? Whatever you know. What do you know about momentum? What is momentum?
Momentum is the quantity of motion.
Quantity of motion. It's okay. I mean, I'm not asking for exact definition. You can, I mean, even if you know equation, whatever you know about it, what do you understand by it? See, motion cannot have quantity. Motion cannot have quantity, okay? So, okay, let me explain. Momentum of an object, you can think of it as how hard is it to stop something. For example, if you have a big truck coming fast, really fast, how hard will it be to stop its way? Or how dangerous will it be to come in its way? I'm sorry, my truck, I just made a box. Or if, for example, you have a rocket. Okay, you have a rocket. What will be more dangerous, coming in the way of the truck or coming in the way of the rocket? What will be more dangerous, more harmful? Sidra? Yes, Alize? It will be more, coming in the way of rocket is going to be more harmful. Why? Because rocket has more mass and more speed. Okay, so you can think of momentum as how hard is it to stop an object. For example, if you have a bullet coming, God forbid, in your way, then now bullet has very high speed, the velocity is high, but mass is less. And so because the mass is less, it cannot make you fly too far. But of course, I mean, it penetrates your body, damages you, I mean, damages your tissues and everything. But I'm talking from physics point of view, it won't make you fall too far because of it's a small mass. Okay, or if a ball comes your way, the ball, because of its small mass. So basically, how hard is it to stop any object? Okay, momentum, according to equation, it is the product of its mass and velocity. It is the product of its mass and velocity. Okay, and the concept of momentum comes in when two objects interact with each other. What do I mean by interact? Meaning they come into physical contact with each other. They can be colliding with each other, or they might be, you know, touching. It depends upon the velocity with which they are approaching each other. Okay, now let's discuss the units that, what are the SI units for momentum? Now, because momentum is a product of mass and velocity, we use the SI units that are used in IGCSE are kilogram for mass and meters per second for velocity. So if you multiply them, the unit for momentum that we get is kilogram meters per second. So remember, these units are very important. If in the question they give you grams, you will have to convert them into kilograms. If they give you centimeters or kilometers, you will have to convert them into meters. And if they give you any other unit for time, those also need to be converted into seconds. Okay, so remember this unit only. There's another unit, okay, and I will come to how this unit, Newton's second, is also a unit for momentum. Now we will make use of the acceleration definition, or the equation for acceleration, which is the rate of change of velocity. Remember, acceleration is the rate of change of velocity. So if we rearrange this equation, the change in velocity or velocity is the product of acceleration and time. A for acceleration and T for time. And if we substitute this equation, or in this equation of momentum, instead of velocity, we write acceleration and time, because velocity is equal to acceleration and time. So instead of writing mass into velocity, I wrote down mass into acceleration into time. And we know from Newton's second law of motion, that force is equal to mass into acceleration. So that means mass into acceleration, this part here is force. This is force multiplied by time, momentum. So we are bringing in other equations, and so we are rearranging this equation. This particular product, force and time, gives you another quantity, which is called impulse. Now, what is impulse? Impulse is for how long did the force act on the object? Force and the time for which it acted on that object. So if we use this equation, force unit is Newton, and the unit for time is seconds. Using this equation, we get the unit Newton second. So both the units are acceptable for momentum, kilogram meters per second or Newton second. Also understand that momentum is a vector quantity, meaning it has both magnitude and direction, and it will have the same direction as the force acting on the objects, which in turn will be the same as the direction of the movement or the direction of motion of the object. Okay, so usually the direction at which the object is moving will also be the direction for the momentum. And of course, that will also be the direction of the force acting on that object. Okay, so this is basic discussion and explanation for momentum, and then we'll do a few problems. Now let's discuss principle of conservation of momentum. Does anybody have any idea of what this means? You know, conservation. Conservation means to save, to store, right? Store meaning whatever you have, you keep it that way. You don't let it get wasted. You don't let it get spent, but it stays there. Conservation, you conserve energy, you save energy, like saving. You can call it, you can think of it as saving. So what does it mean? Principle of conservation of momentum. Any ideas? Any hand raised? Sidra? Any ideas?
Is it the
Yes, yes, Abdul Rahman. Yes, that's
ma'am?
yes.
Is it the stored force?
No, beta. See, pay attention to the words. Conservation of momentum. So that means saving
Stored
momentum.
momentum.
Yeah. Don't use the word store. I just used it for explanation purpose. Saving is a better word. Saving momentum.
Okay,
Like, you know, conserving energy, saving energy, or saving momentum. So this means that momentum before interaction, and remember the concept of momentum is only when two objects interact with each other. Okay, so that means there is some momentum before they interacted and there is some momentum after they interacted. So before and after, because they are conserved, they will be equal. So momentum stays constant before collision, after collision. So the principle of conservation of momentum is nothing but that the sum of momentum of the objects interacting before collision will be equal to the sum of momentum of objects that are interacting after collision. That's all, provided no external forces are acting upon them. What do we mean by that? Meaning that if something, for example, this box A slides and hits this block B, but if you stop the block A, or if there's some resistance or some opposing force, then of course this momentum will change. I mean, you know, this force will have to counteract that other force which is opposing the motion of this A. So then this whole thing will no longer be valid. Okay, because the velocity will be lost in counteracting that force which is opposing the motion of block A. Okay, or if there's constant force which is further pushing A or pushing B farther away from A, then you know the whole dynamic changes, and this is no longer valid. So this is valid only when the two objects are continuing with their motion without any external force interrupting their motion in any way, whether decreasing or increasing, doesn't matter. But no force should interrupt in between while they are in motion, or while, in motion, before interaction and after interaction. So only in that condition, this principle of conservation of momentum will hold true, right? Now, let's take this example to understand how the calculations will be done. So we will make use of this law and this principle of conservation of momentum to make calculations. For example, I have block A, the mass of which is 60 kilogram, okay? And its velocity is 3 meters per second. Another thing, we use the symbol U for initial velocity. Initial velocity meaning velocity before collision. And we use the symbol V for final velocity, meaning velocity after the collision. So UA, meaning initial velocity of block A, was 3 meters per second. And because velocity is a vector quantity, you should put an arrow as well. Okay, now this is stationary, so velocity is 0. Okay, can you hear me?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, good, alhamdulillah. Okay, so when block A collides with B, somehow they stay connected, they stay attached, and then they move together. This is, you can call this inelastic collision, but don't go into the types of collision. That's not included yet in your chapter, but this is called inelastic, meaning that they did not rebound, they didn't separate. In some collisions, the two objects will separate. So that means if the two objects separate, they will go in different directions, okay? Now, I will give you another example of those, okay? Those are called elastic collisions. This is inelastic collisions in which they stay attached and then they move together. So now they're behaving as one mass. This will be one mass. And because they're moving together, they will have the same velocity. So I have used the symbol V for final, and so we have to find out. We don't know, okay? But the direction is the same. Okay, so sum of momentum. Momentum we know is the product of mass and velocity, okay? So mass of block A multiplied by the velocity of block A before the collision, which was 60 kilogram and 3 meters per second. Then mass of B was 30 kilograms and it was at rest, so 0. And I put them in brackets because I don't want you to add before you multiply. So you have to multiply within the brackets first, and then you will add the two products. But because this is 0, so no need to write, right? Because this will end up with 0. Anything multiplied by 0 is 0. Now, this is the sum of momentum of the same two blocks after the collision. The mass will stay the same. The mass will stay the same, 60 kilograms, 30 kilograms, but we don't know the final velocity. But because both of them are now moving together, they have the same velocity, so I gave them the same symbol in order to remove confusion. Because if you have two different variables, it's confusing because they're the same. They will be equal. So when you have the same variable, you can just simply add the constants, and so the rest I think you understand, right? And you just solve algebraically, and you will get 2 meters per second. Okay, I solved this separately, but you should do it like, mass should be taken 90, because now it is behaving as one mass, and the final answer will be the same, by the way, but it is better to avoid confusion. Take this as one mass. If they stay attached and move together, consider them as one mass, add their masses, and multiply by the final velocity, because they both are moving with the same velocity. Okay, so this is how, and another thing, because velocity is a vector quantity, I would advise that you take one direction, choose any direction, and choosing the right direction to be positive is convenient for calculations. And so whenever you are dealing with a velocity towards the right side or momentum towards the right side, it should be given a positive sign in your calculations. And if something is moving towards the left side, its velocity as well as its momentum should be given negative sign. This is to avoid errors, and you will understand this better later. And this is helpful, especially if after collision, they move in different directions. They separate. When they separate, then you will have to use different signs because they are in opposite directions. Their movement is in opposite directions. Okay. So, okay. Now, what is the relationship between force and momentum using these equations? So we know acceleration is the rate of change of velocity, right? I've done this before. V is for final. So how do you find out the change in velocity? By subtracting the initial velocity from the final velocity and divide that by time, and you'll get acceleration. Substitute that into this Newton's second law equation. Force is equal to mass into acceleration. And substitute the value of acceleration from this equation into this, and you multiply mass by the final velocity and then by initial velocity, and this is what you get. But what is this? What is this numerator? This is change in momentum, meaning initial momentum subtracted from final momentum is change in momentum. And change in momentum divided by time should be equal to force, according to this equation that I got from Newton's second law. So what is this? Change in momentum divided by time is the same as the rate of change of momentum. Rate means that how does one quantity change with respect to the other quantity? And here in this case, we are considering the change in momentum with respect to time. Therefore, we will call this whole thing as the rate of change of momentum. Now, if I cross multiply, then I can rearrange this as force multiplied by time is equal to change in momentum, right? And force multiplied by time was impulse. So that means impulse is equal to change in momentum. Also remember, force is equal to rate of change of momentum. Okay, and now you understand why momentum also has Newton's second also as its units, because force is in Newton and time is in seconds, right? You know, students make a list of equations and formulae, and then they learn. I find that hard. And you know, if you understand their derivation this way, then it will be easier, because if you are convinced why this is so, you are convinced now, right? You should be convinced. You should not just ratify that force is equal to the rate of change of momentum, and, you know, impulse is equal to change in momentum and this and that. You know, if you have so many equations to ratify, at the end of the day, you'll get confused and you'll forget them. But if you go logically and you convince yourself, then it'll be easier for you to understand. It'll stick to you. You won't go wrong and you won't get confused. Now, let's incorporate Newton's third law of motion along with momentum. What was Newton's third law of motion? Can anybody remind us? Sidra, you remember? Yes, very good. Anybody from the participants? Does anybody remember what Newton's third law of motion was?
Action, reaction.
Very good.
Interior.
Very good. Yes, action, reaction. Every action has a reaction. So now we will incorporate that with momentum. Take this example. This example was given in your book. If you remove the string or whatever is holding this balloon, what will happen to the balloon? It'll deflate and will fly all over the room, right? And so some gas is released, some air that was trapped inside will be released. And so that air or gas that is coming out has its momentum exactly in the opposite direction to the momentum of the balloon. Okay, so this is action, reaction, or action, reaction, whatever you want to say. So two equal and opposite forces are acting. Okay, because the forces are in the opposite directions, therefore their movements are in opposite directions, and therefore their momentums are in opposite direction. Okay, same is the case with rocket. When the rocket is launched, what happens? Fuel burns and a lot of gas is released. That gas has a momentum of high velocity steam. And of course, the direction of that momentum is downwards towards the ground. And therefore, there is an equal and opposite force acting upon the rocket, which gives it an equal and opposite upward momentum. And that's what pushes the rocket upwards. Okay, this is another example. And then they have talked about the jet engines in your book. Okay. And so, okay, let's talk about some of the pictures that they have given in your book. They have talked about impulse and collision time. Impulse and collision time. I cannot show the book. This is page 48. I cannot show the book. Okay, leave it. Now, have you, well, especially the boys who play cricket, my question for them, those of you who might have tried to catch the ball while fielding in cricket, if you cup your hand this way, the way they are cupping here in this, your book, in this picture, in your book, can you see how they are cupping their hands? And they're like sort of moving back with the ball. What is the advantage of this posture? And how would you compare this with a person who is standing straight and is just, you know, bluntly trying to catch the ball without cupping? I mean, have you ever tried to catch a ball without cupping your hands, and how does it feel? Has any boy done that? And how
Ma'am,
does this? Yes.
if you do it without cupping, it'll just reflect, it'll just hit your hand and just fall down.
Okay, have you
Without
tried doing
cupping.
that? How did it feel on the hand?
It hurts.
Yes, it hurts. And if you hold this way, if you try to catch the ball this way,
The ball will come right into your hands and you can grab it.
and it hurts less, right?
Yeah.
Yes, it hurts less. And if you just, you know, straight away try to catch the ball without cupping, you can have that tingling and burning sensation in your palm because the ball came with a lot of velocity, with a lot of speed. It hit your hand with a lot of speed. So what happened there? What happened? Let's see. Okay, let me zoom out. Okay, so now ball has, I'm using this equation to explain what happened. Now, the mass of the ball will stay the same, right? And the ball is coming with a lot of speed. The final velocity with, I mean, after hitting your hand would be 0 because you will be stopping it, right? You are stopping it. So final velocity will be 0. And it is coming with some very big velocity. Let's say 100 meters per second. Okay. So the impulse would be, now this is 0. So this is anything multiplied by 0 is 0. So the momentum is that velocity multiplied by the mass, that velocity with which the ball is coming towards your hand and multiplied by its mass. Okay. Now, if the velocity is too high, the whole thing is going to be a big number. Okay, it's going to be a big number. Now, it has to be equal to this impulse. Now, if you just without cupping, you try to catch the ball without cupping, what happens is that your time of contact, the force that you are applying with your hand, the time of contact is really small. The time is, for example, 1 second. Now, it has to be equal to 100. In order to be equal to 100, now force will increase to 100. because this has to be true. Okay, so if time is less, force will be 100 newtons. And so that is why your hand will have a burning sensation, because it hit your hand with such a lot of force, right? Now, what happens when you cup your hands? You increase this time. And if you move back a little, you increase the contact time between the ball and your hand. So the ball comes into your hand gradually. So you increase this time, maybe 5 seconds or 6 seconds or 7 seconds or whatever. And so that considerably decreases this value. Do you understand? So this value decreases. So that means now the ball hits your palm with less force. And so you have less burning sensation or no burning sensation at all. Do you understand? So that is why cupping is helpful. Same is the case with this batsman, whatever you guys call this person. Now, what is he doing? He's doing the same thing. Now the ball is coming this way towards, and this is his bat. Okay. Now the ball is coming this way. It has big velocity. Let's choose a big number, 1,000 meters per second. That multiplied by mass, its momentum is really high. Now, what will this bat do? This bat will change its direction. I mean, the velocity will not be 0, but it will be something like, if, for example, you're taking this to be positive, the bat will give it a velocity in negative because the ball will go in the other direction. The ball will go in the other direction. So it has to change. This change is really big, is even bigger than what we discussed in case of catching. Okay, this is even big because it's not stopping, but it is causing it to move the other way. So for that, you need a big impulse. You need a big impulse. So in order to help with that, what the batman should do is that he should follow the ball for as long as he can. Can you see? I mean, he hit the ball when the bat was here. So what was the point of taking the bat all the way up? The reason why he's like sort of following the ball. Why? Because he is trying to increase this time, the time of contact between the ball and the bat. So if the time increases, he has to exert less force. If the time increases, he has to exert less force to cause this momentum change. Do you understand? And that's why swinging the bat is helpful if he wants to throw the ball with greater speed. You understand? Greater speed, this speed. He's trying to give this ball a greater V. Okay, U was what it came towards it with, that velocity. Okay, I hope this made sense. Then here, this picture, what is this picture showing us? Again, I'll zoom in. She's an athlete and she's jumping, maybe some long jump. And so they provide them with this sand for landing purpose, for jumping purpose. Why? Because when she, digs into the sand and when she slides in, she's increasing the contact time. Again, she's increasing this contact time. And this increase in contact time results in less force being applied by the sand on her. And so she doesn't get hurt. I mean, just imagine she making this jump on a hard ground. What happens? The time will be less, and so more impact, greater impact of force, and she might get hurt. Did I make sense to you? Did this make sense?
Yes, miss. Yes, ma'am.
Okay, good. Okay, so, and then there's another thing that they have talked about, and that is the crumple zone in cars. Let me show you 58, page 58. Crumple zone in the cars. This picture, this one. You know, when they design cars, they make sure, what is a crumple zone? Crumple zone is from the front of the car all the way till the passenger. That is called the crumple zone. From the front of the car, can you see the whole front of the car is crashed in this? And the passenger is here. So they increase the crumple zone. They want to lengthen the crumple zone. Why? Because longer the crumple zone, more the time you will get. And so less the force on the passenger. And so less chances of injury. Do you understand? So if the crumple zone is longer, the impact will take more time because, you know, it will take time to reach to the passenger. And so time will increase and therefore less force on the passenger. Okay. Okay, now, is there any question? Any question at all? I won't mind. You're most welcome to ask. Or should we go on to the end of chapter questions? Are there any past paper questions that you want to solve? Please let me know. Okay, let's do these questions. What is the momentum in kilogram meters per second of a 10 kilogram truck traveling at 5 meters per second? Okay, 5 meters per second. So this is easy. I have done these already for you so that you save time. Okay, let's see. Yes. So we will just use the formula for momentum, which is the product of mass and velocity. Okay, mass is 10 kilograms and velocity is 5 meters per second. Just simply multiply. Okay, no straightforward question. Part B, momentum again, product of mass and velocity. But here they gave you unit centimeters per second. Centimeters per second. So we need to convert this. Second is fine, but centimeters need to be changed into meters. How will we change? That's easy. You guys should tell me. How do you convert centimeters into meters?
Divide by 100.
Very good. Yes, divide by 100. Why? Because there are 100 centimeters in 1 meter. And so 20 centimeters will have, so 20 divided by 100. Okay, so 0.2 meters. When you multiply 0.2 by 10, we get 2 kilograms meters per second. Okay, then again, here, the momentum is given in kilometers per hour. So now both the units need to be converted. First, let's convert the kilometers into meters. How do we do that? Come on, you guys tell me. How do we convert?
Multiply by 1000.
Right, multiply by 1000, right. So because meter is a smaller unit than kilometer, so we'll multiply, right? 1 kilometer is equal to 1000 meters, and so 36 kilometers will be 36 multiplied by 1000, 3600 meters. But then we have to convert hours into seconds as well. Okay, so 1 hour has 3600 seconds. So in 3600 seconds, this distance is being covered, 36,000. So in 1 second, how much distance will be covered? 36,000 divided by 3600. Because the speed is the distance which is traveled in per unit time. So I have to find out how much distance is being covered in per unit second, per second. Okay, so if I know that this distance is covered in 3600 seconds, I can find out how much distance is covered in 1 second. So I will divide 36,000 by 3600 and I get 10 meters per second. So now I can multiply this velocity with mass to get the momentum. Okay. Have you guys done these questions already? Or should I discuss them with you?
Miss, could you discuss?
Sorry? Because, you know, if you guys have done this already, then you might get bored. Okay, question number 2. A ball X of mass 1 kilogram traveling at 2 meters per second has a head-on collision with an identical ball Y at rest. X stops and Y moves off. What is Y's velocity? Now in physics, remember when you get questions like these, like story type questions, always draw diagrams. Diagrams will help you in visualizing what's happening, and that's very, very important in physics. Okay, so here's my diagram. So there's ball X. It has a mass of 1 kilogram and it is moving with its initial velocity 2 meters per second. Why I wrote X? So that I know that this is ball X's initial velocity. U is for initial velocity, 2 meters per second. This other identical ball, they use the term identical. Identical meaning same mass. Same mass. So if ball X has 1 kilogram, ball Y will also have 1 kilogram mass. Okay, and it is at rest. That means its initial velocity is 0. This is before collision. Now, after collision, what happens? That this stops, X stops. So its final velocity is 0. Mass stays the same. But Y gains some velocity that we have to find out, and its mass is the same. Now, first I will decide now, because the initial and the final directions of velocity are the same, plus minus thing won't come in here. But still, I have taken rightward the direction as positive. Okay. Now, sum of momentum before collision is equal to, now we are making use of the principle of conservation of momentum, which states that sum of momentum before collision is equal to sum of momentum after collision. So mass of X multiplied by the velocity of X. So 1 multiplied by 2. Okay, 1 multiplied by 2. And then this was 0. In velocity is 0. 1 multiplied by 0. So 0. And then mass is 1, but the final velocity is 0. And mass of Y, which is again 1 kilogram multiplied by its final velocity that we have to find out. So this sum of this is 2. Okay. Sum, and here we have only V of final velocity for Y, which is 2 meters per second. And because this is in positive, it means same direction as ball X, towards the right. Okay. Is this question clear?
Yes, ma'am.
Okay.
Yes,
Is
ma'am.
there any question that you guys think is difficult, and or should I do all of them? Okay, so now question number 3. A boy with mass 50 kilogram running at 5 meters per second jumps onto a 20 kilogram trolley traveling in the same direction at 1.5 meters per second. What is their common velocity? So that means the boy has jumped. So again, I have made a diagram. The boy has jumped into the trolley and now they're moving as one body, like one object. Okay, so this is okay. So again, rightward movement is taken as positive. Okay, sum of momentum before collision. But again, here the direction is the same. So plus or minus won't matter. Plus and minus is important when the final direction is different, or if any of the directions is different from the other. That's when plus and minus become important. So sum of momentum before collision. Again, mass multiplied by velocity, mass multiplied by velocity. Okay, is equal to sum of momentum after collision. I added up their masses, 50 plus 20, 70, and then the final velocity. So then it's easy, just solve it and you will get final velocity 4 meters per second. Is there any confusion in this?
No, ma'am.
Come on, guys, at least respond, say yes or no. Okay.
No.
Are you guys sleeping? I know online classes are boring. It's very hard to concentrate. I know that. I know that. Okay. Question number 4. a girl, but I hope you guys are not sleeping. You guys are with me. Are you?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Jazakallah khairan. Okay. A girl of mass 50 kilogram jumps out of a rowing boat of mass 300 kilograms onto the bank with a horizontal velocity of 3 meters per second. With what velocity does the boat begin to move backwards? Backwards. So again, I made a diagram. This is a boy in the boat. The boy jumped forward with a velocity of 3 meters per second. And of course, he must have come to a stop, right? After the jumping. So the final velocity must be 0. And the boat must be, I mean, when the boy is jumping, the boat must be at a stop. The boy won't jump until the boat has come to a stop, right? So its initial velocity, I mean, before the jump was 0 meters per second of the boat. And the boat direction, movement of direction is opposite to the direction of movement of the boy. Now, final velocity of the boat is what we have to find out. Okay, taking the forward reaction as positive and the backward as negative. Again, we will apply the principle of conservation of momentum. Okay, 50 multiplied by its initial velocity, 3 plus the mass of the boat and its initial velocity, which is 0. Then sum of momentum after collision, again, mass multiplied by its final velocity, which is 0. And then I used negative sign because the momentum of boat is backwards. The momentum of the boat is backwards, and therefore I used negative sign. 300 mass multiplied by its velocity that we need to find out. Now I solve this 150, this is negative 300. So my final velocity will be in negative. This shows that the movement of the boat was backwards. Okay, it was not in the same direction as the boy. Okay, but otherwise the calculation is the same. Is there any confusion, any question in the, any question regarding this? Okay, question number 5. A truck of mass 500 kilogram moving at 4 meters per second collides with another truck of mass 1500 kilogram moving in the same direction at 2 meters per second. What is their common velocity just after the collision if they move off together? Okay, again, I have made this diagram. This was the truck. Mass is 500 kilogram. Initial velocity is 4 meters per second. And it collided with another truck with a mass of 1500 kilogram. And this truck was moving with 2 meters per second, same direction. So all directions are the same. Then after collision, they move together as one object or one mass, and we have to find out its final velocity. Again, principle of conservation of momentum, same thing. Mass multiplied by velocity and plus of this truck plus the momentum of this truck, 1500 multiplied by 2. I solved them, and so velocity is 2. The final velocity of the two objects is 2.5 meters per second. Positive meaning in the same direction as the two trucks. Okay, easy questions. Are the past paper questions trickier than these?
Yes.
Okay, so you should have
Yes.
brought, have you guys done these questions in the class? The ones that I am discussing right now? Now, don't
Not
tell me that,
mine.
oh, we had already done these questions.
No, it's not mine.
Oh, okay. Okay, so now question number 6. The velocity of a body of mass 10 kilogram increases from 4 meters per second to 8 meters per second when a force acts on it for 2 seconds. Okay, so what is the momentum before the force acts? Okay, So now the fact that they have given you time, they have not given time in any of the other questions. The fact that they have given you time shows that they want you to use the concept of, the fact that they have given you time shows that they want you to use which concept? Come on, who will tell me? In which equation did time come? The equations that we have
Ma'am,
discussed.
the v minus q divided by t.
Sorry?
V minus
Sorry?
q divided by t.
No, beta, answer my question. I'm asking what equation has time in it? Where did we come across time? What do they want us to apply? Which concept?
Ma'am, force multiplied by time.
Yes, and that is called, force multiplied by time is called
Momentum.
momentum.
Impulse.
Thank you very much. Yes, that's impulse. Okay, momentum is what? What is momentum? Just give me equation. Forget the definition. Formula for momentum.
Mass times velocity.
Yes, mass multiplied by velocity. Okay, so force multiplied by time is in impulse, and momentum is mass multiplied by velocity. So if they have given you time, that means they want you to use the concept of impulse. Okay, so I have written impulse is equal to change in momentum. I know that. Why do I know that? I didn't memorize it. I'll tell you how. Force multiplied by time is equal to change in momentum. Change in momentum is this. I remember this, and I know that force is mv minus mu over t. Why? Because I know force is equal to mass into acceleration. Because, you know, m will come out as common, v minus u acceleration. So do this real quick. Do this real quick in your mind. Either you do this, whatever works for you. If you can do this, this is easier for me. But then if it doesn't, I mean, of course, if nothing works, then of course you will have to resort to learning. But anyway, part A is asking, what is the momentum before the force acts? Before the force acts. So multiply mass by its velocity. The velocity before the force act was 4. So 10 multiplied by 4, you will get 40 kilogram meters per second. That's the answer. Part B, after the force has applied. What is the momentum after the force is applied? So the velocity after the force is 8 meters per second. So I will multiply the mass by this final velocity. Mass multiplied by this velocity after the force has applied. So 80. Okay, momentum gain per second. Per momentum gain per second. So this is before the force is applied. After the force is applied, what is the gain? Meaning, what is the difference? Difference is 40. 80 minus 40 is 40 per second, meaning this change took place in 2 seconds. So what will be the change in 1 second? Divide by 2. And this is also the formula. Momentum, rate of momentum, rate of change of momentum is, the formula is this, rate of change of momentum, right? Change in momentum divided by time. So 40 divided by 2 is 20 kilogram meters per second square. Why did I write square? Can anybody explain me? Why did I write square? You know what? Play with the units. What was the unit for this? What was the unit for momentum? Unit for momentum is kilogram. Let me do it here. Okay, mv minus mu over t. The unit for this whole thing is this, kilogram meters per second. And the unit for time is second, right? And so this is the answer. That answer that we're getting is this, right? So what is the other way of writing this down? Isn't it the same thing? And then isn't this, can we write it this way? Can we write it this way? You
Yes, ma'am.
understand this? This fraction bar means
reciprocal.
division, right? And if I convert that into multiplication, I'll have to invert this. So then this results in what? Right? Kilogram meters over second square. I should have written it this way. Kilogram meters over second square. So be careful with the units. Always be mindful of what quantities you're dealing with and what should be the final unit. Okay, so momentum gain per second. This is the rate of change of momentum. Okay, this is the rate of change of momentum. Okay, now part D. Part D, what is the value of the force? Remember when we discussed the rate of change of momentum is equal to, where did that go? The rate of change of momentum is equal to what? Look at this. Oh, I cannot show this. Move this book. Here, rate of change of momentum was force. Rate of change of momentum was equal to force. This is the rate of change of momentum is equal to force. So they are asking the same thing. They first made you calculate the rate of change of momentum, and now they're asking what is the force. It's the same. It's the same. It is the rate of change of momentum. So rate of change of momentum was 20. Force will also be 20, but only that you will change its unit to Newton. That's it. Same thing. And this is how you're going to do. Force is equal to rate of change of momentum. And then that's it. And rate of change of momentum is this. And so force is equal to 20 Newton. That's it. No working. Any question regarding this? Question number 7. Any confusion?
No, ma'am.
Okay. Now, question number, that was question number 6. Sorry, now this is question number 7. Okay. A rocket of mass 10,000 kilogram uses 5 kilogram of fuel and oxygen to produce exhaust gases ejected at 5,000 meters per second. Calculate the increase in its velocity, meaning calculate the increase in the rocket's velocity. Let's again make a diagram, try to understand the scenario. This is a rocket, some fuel is burning inside. And so a high steam velocity is being given off in the downward direction. And so as a result, equal and opposite force on the rocket. So an equal and opposite momentum on the rocket, right? Now, the mass of rocket, according to the question, is 10,000 kilogram. I mean, of course, it was initially at rest. So the initial velocity is 0. Final velocity is what we have to find out. Now, what was the mass of this steam? What was the mass of this steam is the same as the mass of the fuel. Because whatever fuel is burning, it is getting converted. All of it is getting converted into steam. This you should know from chemistry. Remember, all the hydrocarbons undergo combustion with oxygen and they give carbon dioxide and water. And it is carbon dioxide and water that is coming out. So, okay, principle of conservation of mass, you can say. So this is 5 kilogram, okay? Initial velocity was 0 and the final velocity was 5,000 meters per second. And I gave it a negative because this is in the opposite direction. So I have taken the upward velocity as positive and downward velocity as negative. Now, sum of momentum before collision, I took both their masses. I added both their masses because initially they are one object, one mass. So I added them, but it doesn't matter because eventually the mass will get multiplied by 0. So, but you should take the masses together. Okay, then After collision, then this mass of the rocket multiplied by its final velocity that we don't know. And then negative, why? Because now the momentum of the steam is in the downward direction, and I took this. So mass will be 5, velocity is 5,000 negative. Okay, if I algebraically solve it, this 25,000 will go on the other side of the equation, will become positive. I will divide that by 10,000 and I will get 2.5 meters per second. This will be upwards. Why? Because according to my question, upward is positive, and of course the rocket will go upwards. So is there any question? This was an easy chapter, wasn't it?
Yes.
Yes, ma'am.
Yes, ma'am.
So you guys asked for this topic. Okay.
Ma'am, the problem